Good morning and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And I want us to respond to question number 5, exam practice of sets 3. And this question is talking about there are 40 people in a dance class. All 40 can do at least one of the dances. Note the word all 40. That means there is no one in that class who does not have at least something to do. Everybody is going to have something to do. What are the dances? There is waltz dance, there is jive, and there is tango. And the information that we have is that 30 people can waltz, 21 can jive, you can see that, and 14 can tango. That is the information that we have. Further information says that 13 people can waltz and jive. Waltz and jive, 13 people. 6 can jive and tango. Jive and tango, 6 people. And 11 can tango and waltz. Tango and waltz, we have 11 people. A person is selected at random. Work out the probability that he will be he can waltz, at the same time he can jive, at the same time he is going to tango. In other words, find what is the probability of picking somebody who is going to do all the three, because he's going to be in the inner intersection. Part B, we are going to explain. And for this one, we are going to come up with a Venn diagram that is going to have 3 circles. And you're going to have waltzing there. We are going to have jive, that circle, and you're going to have tango there. Note, there is nothing outside the 3 circles because everybody is engaged in at least an activity. But because we are not told how many people are going to do all the 3, and we know we fill our Venn diagram from the inside or from the innermost, let us indicate that there is X there. And X are the number of people who are doing all the three, yes. But from this information, we can already see that people who are going to waltz and jive are 13. Waltz and jive are 13. So in this section, we have 13 people, within which we already have X. So outside here, we have 13 minus X already. 13 minus X. And jive and tango 6, J and T we have 6, and with this is the intersection we are talking about, and within it we already having X, so outside here we are having 6 minus X. We have taken care of that. T and W, tango and waltz, T and W we have 11. Inside here, this is the intersection we are having. Inside that we already have X, so outside here we have 11 minus X. We have taken care of that also. Let's now go to the outside now. We are having 30 people who can waltz. This circle has 30 people. And within it, we already have 11. We already have 11. We already have 11 minus X. We already have X, and we have 13 minus X. We have 11 already plus 13, which is 24, minus X plus X minus X. So this minus X and this plus X will cancel out. So we are going to have 24 minus X. So because we are having 30 entirely who are going to tango, so outside here we are going to have 30 minus 24 minus X. And this is like we are having 30 minus 24 is 6, minus X is plus X. We are having that. So jive, we are going to have 21. And already we are having 19 here. 13 plus 6, 19, plus X minus X, again minus X. So as we can see, we are going to have 21 minus the entire what we have, 19 minus x, which is 2 plus x. So here we have 2 plus x. And in this particular one, so we have taken care of that and that. Tango, we have 14, and 14 people can tango, and we already have 11 minus x plus 6 minus x. We already have what? Who can tango? We already have 17 minus x plus x goes away. We have 17 minus x. And because we are told that 14 can tango, so 14 minus what we have, 17 minus x, this is going to give us minus 3 plus x. So outside here we have minus 3 plus x. And that is just like it. So what do we need to do? The first thing we need to do is we have to find the value of x. And what we need to know is that all these added together should give us 40, because there is nobody who is idle. Everybody is doing something. So what we have, 6 plus x, we are through with that, okay, plus 11 minus x, we are through with that part, plus x, this part, plus 13 minus x, that part, plus 2 plus x, that part, plus 6 minus x, that part, and finally minus 3 plus x. All this should give us 40. So let us see what we have. And we are going to add everything here. 6 plus 11 is 17. Let us have 6. 6 plus 11 is 17. 17 plus 13 is 30. 30 plus 2 is 32. 32 plus 6 is 38. 38 minus 3 is actually 35. That is as far as the whole numbers are concerned. What about x's? Plus x minus x plus x minus x plus x minus x plus x. So plus x is equals to 40. And you can already see that x is equals to 40 minus 35, which is 5. That is the value of x. And if the value of x is 5, then we can answer all the questions. What is the question? What is the probability of finding one who is in W intersection J intersection T, the innermost intersection? Of course, because x is 5, then we are going to have 5. The probability of finding somebody who is in all the three is 1 of the 5 out of the total 40, which is 1 over 8. And that is the answer to part A of the question. Part B of the same question, let's work it out. This is part A. Part B of the question is the probability of picking somebody who is going to do tango, given that he is also in the jive. Now, we said that given that is a condition, and it reduces now the denominator, because we are only supposed to consider those who are doing the jive. And how many people are doing the jive? Only 21. So our denominator changes. Find the probability that somebody is going to tango, given that he's also doing the jive. So we are talking about this intersection. There is intersection here, this one, going to tango, given that he's going to jive also. Within that intersection, we have x, which is 5, 6 minus 5, that is 1. So 5 plus 1 is 6. Out of the total possible, those who can jive, 21. And this is reducing to 2 over 7 when you divide everything by 3. And that is the answer to part B of the question. So this is it. Part A is there and part B is there. Thank you for following me. That's the end of the topic, and see you in the next video.